This is the brief on the vector calculus of rigid body rotation. So, we're looking at the mathematical blueprint for how a rigid body spins around a fixed point. And what's really cool is how we can use a couple of powerful tools from vector calculus, divergence and curl, as sort of instant detectors. They reveal the fundamental forces and motions at play. All right, first, let's think about the velocity field. When you apply the curl operator to it, it acts like a little sensor for the body's local spinning motion. This measurement, its vorticity, turns out to be directly proportional to the body's angular velocity. It tells you exactly what the spin is doing right at that point. Second, let's look at the acceleration field. If we take the divergence of this field, which basically measures how much it's collapsing inward, we get something crucial. The result is tied directly to the centripetal force. That's that inward pull required to keep every part of the body moving in its circular path. And finally, if we take the curl of that same acceleration field, it isolates the tangential force. This is the force that's actually responsible for changing the rotation speed, making the body spin faster or slower. So by analyzing the divergence and curl of these fields, we get an immediate and clear picture of the underlying dynamics that govern the entire rotation.